my skills through. And I'd like to take a second to thank you and welcome you.
Thanks everybody, thanks for coming, and thanks for the invitation to moderate. So my name is Kapil, Dandekar. I'm the Associate Dean for Research and Graduate Studies in the College of Engineering, and I'm happy to moderate this panel on interdisciplinary research. I think we have two really good talks today to talk about and illustrate some ideas with interdisciplinary research. And I'm hoping that we'll be able to use this opportunity to hear some stories from everyone in the audience as to what they consider to be interdisciplinary research, what strategies have worked for interdisciplinary research, maybe what hasn't worked so well, what are some of the challenges that are involved, and talk about that. And if I could just say a few words about interdisciplinary research. I mean, I think that you all in graduate school right now working on research, this is a great time for you to be looking at interdisciplinary research. When you're in a university setting and you can go down the hall and hear a seminar from someone who's working in a radically different field than you, that's an opportunity that's you should definitely seize while you can while you're in a university setting. Because if you go out into the real world and you go to a large company, maybe you won't run into someone who's working in a radically different area that can give you ideas that could lead to interdisciplinary research. From my own personal experiences with interdisciplinary work, I mean, I started working at the Naval Research Laboratory, quite a while ago, and one of my experiences there working as a programmer and as an engineer was that when you work with cognitive psychologists or people who are interested in like human factors and items like that, there are a lot of interesting discussions that come up that wouldn't occur to you if you weren't if you're just developing code. You don't necessarily think about what's the psychology of the users who are using systems and how do you design them to take that into account. Flash forward to my PhD dissertation. I did some work with electromagnetics and communication systems. I had faculty advisors and colleagues who were working in both of those areas, and I like to think that my dissertation kind of bridged those two disciplines together. Interdisciplinary research often is a good place to look for challenging problems for a master's thesis or a PhD dissertation. In many cases, I've always felt that the work that hasn't been done yet, you have to look at those intersections between different disciplines in order to find the really interesting and challenging problems. But at the same time, as researchers, we also need to be realistic, right? It's not interdisciplinary research is not all rainbow and gumdrops, right? I mean, there's downsides of doing interdisciplinary research too. Sometimes it's just too hard. The disciplines are just too far apart in order to get meaningful collaboration together. Other times, it's hard to get work that's interdisciplinary to be appreciated by the scientific community, right? If you're working in, or take my example, if you're working in communications and you're working in electromagnetics, when you take your communications flavored work to the electromagnetics community, they might not like it as much as they would like pure electromagnetics work, and vice versa. So, there are definitely challenges that are involved with interdisciplinary research. But, one of the things that I've seen going through my career, and you'll hear a little bit more about with Damiano's talk, is, when you do interdisciplinary research, we have a project that's going now on that Damiano talked about with fashion designers and medical doctors, and that can be very, very rewarding and very interesting. So with that, let me introduce our speakers. And what I wanted to say is just kind of how I see this panel being run. I'd like to invite both of the speakers up to give some remarks, and ask them to make it not a purely technical talk, so that they can talk a little bit about what motivated them to follow the paths that they're on. But after the two talks, I'm hoping that we'll be able to have a panel discussion, and where everyone in the audience can talk a bit about how they've been exposed to interdisciplinary research and what they see as some of the opportunities and some of the challenges that are involved in doing that. So with that, let me introduce our first speaker, Damiano Patron. He's a PhD student. He's actually working in my laboratory, the Drexel Wireless Systems Laboratory, in the area of telecommunications. He has a strong passion for electronics and radio frequency science that he developed at a young age. Receiving amateur amateur radio license at the age of 16. He received his high school degree in electronics and communication and a bachelor's degree in electronics engineering from the University of Padua in Italy. In 2011, he joined Drexel as an MS PhD student, completing his Master of Science degree in 2013. His research interests include the design of antennas for wireless networks and fabric-based wireless sensors for wearable antenna applications. He's also been the author of numerous scientific papers and the author of several patents in the area of antennas and wearable systems. So with that, let me introduce Kapil.
Thank you, Dr. Dandekar. Very good afternoon to all. Today I'm here to present my work on adaptive antennas and for Wi-Fi networks and wearable applications. So, just to give you a brief description about my personal interest, I started my passion for radio communication and antenna as an amateur radio when I was 16. And I thought that this picture explained very well my who I am and where I come from. So I'm from Venice, from Italy, and I've always liked to experiment with electronics and radios since I was very young. And this picture that I added on my slide is called QSL. It's a postcard that amateur radio they exchange to each other in order to confirm a very interesting wireless link. For example, if I was in Italy, when I was in Italy, if I ever had the chance to talk with another amateur radio from US, I would definitely ask to exchange these postcards. After completing my high school degree, I earned a bachelor degree from University of Padua in electronics engineering, and then I joined the company Adante. Adante is a startup company that develops smart reconfigurable antennas for wireless system, and the founder is a PhD student, is a former PhD from Drexel, Daniele Piazza. And after working 2 years in Adante, I joined Drexel University in 2011. This is the outline of my presentation. To begin with, as you see on this slide, I show the evolution of radio communication and its transformation to the current wireless system. I would just highlight about the recent wireless communication system and give us a very brief introduction on what is the basic model of a wireless system. So a wireless system is basically is made by a transceiver, which is the actual radio, responsible of converting the information to a proper electrical signal. And then this radio is connected to an antenna, which transforms the electrical signal into an electromagnetic field. At the Drexel Wireless System Laboratory, I focus on the design of adaptive antennas, so I take care of the antenna parts of radio communication. And I design adaptive antennas for wireless communication and for wearable application. In addition to my passion for this field, I also believe that wireless technologies, especially applied to wearable application, they have great potential for the future of digital communication and for wearable technologies. I would like to introduce now the field of reconfigurable antennas, which is one of my main research topics. Reconfigurable antennas are motivated by the need of designing wireless devices capable of a smart management of the energy that they radiate. On the left-hand side, we can see a picture where we have two wireless networks equipped with conventional static antennas. While these conventional antennas tend to waste the energy around 360 degrees, generating also interference, with our reconfigurable antenna technology, we can steer a directional beam, as I show on the right-hand side. We can steer a directional beam toward a specific user. As a result, we can achieve a stronger wireless connection, and we can also reduce the interference between the different different networks. The research at Drexel Wireless System Laboratory is focused on the development of the next generation wireless devices through the design, prototyping, and testing of wireless hardware. Our team has a very broad skill in the telecommunication field. We design antennas, we also design hardware and we program hardware, and we also develop algorithms. I want to dedicate a special thanks to Dr. Dandekar, director of our laboratory, because in his lab I found a very fantastic environment where I develop my ideas and I work on very exciting projects. So these are two examples of reconfigurable antennas developed at the Drexel Wireless System Laboratory. The first is called the Reconfigurable Leaky Wave Antenna, and the main feature of this antenna is that just by changing a couple of voltages, we can steer a directional beam from the left-hand side to the right. So we can steer a very directional beam to cover, to follow the movement of the user that in the time is communicating with the wireless access point. The second interesting antenna that we have developed in our lab is called the Reconfigurable Alpha Group Antenna. And its feature is that we can generate a single omnidirectional beam, which is this blue curve, so we can spread the energy uniformly around 360 degrees like a conventional static antenna. But at the same time, we can switch to directional patterns. We can select between 4 different directional patterns to focus the energy toward a specific direction to improve the connectivity in a specific direction. So in terms of application, reconfigurable antennas, we can benefit from reconfigurable antenna technology in our everyday experience with the wireless network. As I already said, by focusing the energy toward the specific device, we can get a more reliable connection and faster communication between the user and the wireless access point. Instead of using more power to increase the connectivity, our antenna technology is able to adapt its radiation characteristics to find the best link with the users. Additionally, there is another interesting way of using reconfigurable antennas, and it's called direction of arrival estimation. This technique it allows to determine the best direction to steer the beam because we can estimate the location of a wireless user. As you see here, there is a wireless access point and is able to estimate the angular direction of each user. And we can use such information to improve the connectivity of these devices. For this work on direction of arrival estimation, we have used an improved antenna design that has been developed in collaboration with the company Adapt. This company, Adapt, is currently working with important wireless firms of the Silicon Valley in California, integrating the technology that was developed here at Drexel into consumer and industrial wireless devices. Our design, which is this one, received considerable appreciation, in particular after several demonstrations where the company has shown the performance improvement using this kind of design with respect to the conventional antenna systems. In addition, at the IEEE Conference on Antennas and Propagation in Europe, I received the Young Scientist Best Paper Award for our paper entitled Improved Design of a Leaky Wave Antenna and its Application for delay estimation. I thought that it was interesting to add a couple of pictures from this event. The conference was held in Turin, Italy. The location of the conference banquet was amazing. We were within a beautiful ancient villa near Torino, and the award ceremony was held during this banquet. It took me actually some time to realize that they put my name for the award, because I couldn't. It took me some time to realize that they pronounced my name. It was a great emotion, but at the same time I was hoping that this award could strengthen the technology when it will be possibly proposed for the wireless market. about the second topic of my presentation, which is another field of research, wearable electronics. Wearable electronics is one of the next generation technologies that is growing very, very fast. And they include clothing and accessories that incorporate computer or other advanced electronic technologies. The design often is for, designs are often for practical functions and features for entertainment or helping our everyday life. At the Drexel Wireless System Laboratory, we are working toward this field by incorporating powerless wireless sensing into fabrics and wearable and clothing. Challenges of this technology is the miniaturization, because of course we want to wear the sensor shouldn't be too big or bulky, the durability and the accuracy of the data that we can measure. Here we can see an example of a wearable electronic that is able to measure the heart rate and send the information to a smartphone. And I think you already heard about the Google Glasses. This is another example of wearable technology. So another interesting activity of my research is the design of smart fabrics and antenna, which are accomplished by combining our research in wireless circuits and antenna, along with the collaboration with the College of Media Arts and Design. And here I basically show how we use conductive yarns and conductive fabrics to design antennas and other radio components on fabric. We can design the actual conductive layout of the antenna using conductive yarns, and then we build the rest of the garment using non-conductive fabric support in order to make the rest of the garment of the fabric. So how do we create wearable electronics? We start from an electromagnetic design and simulation of our antenna or radio frequency design, and then we translate this 3D model into the CAD model that is useful for the knitting machine. The knitting machine then are controlled, they follow this CAD model, and they can make the actual prototype of the wearable technology that we design. At the Drexel Excite Center, we have this capability. We can take advantage of these machines to develop smart fabrics for wearable applications. So the application that we are currently investigating in terms of wearable technologies is the wireless monitoring of physiological activities for medical and sport purposes. Basically, by adding a specific powerless chip on the fabric antenna, we can wirelessly detect the movement, like contraction or elongation, of the fabric. As a result, we can open potential application for medical and sport and fitness monitoring. On the left-hand side, we can see the example of our belly band project, and the goal of the project is to replace the current cumbersome probe system that are currently used to detect movement of pregnant women with a more comfortable and wireless band. In addition to the increased comfort using the belly band, we can also install a sort of base station, a small base station, that is able to collect the data that is coming from the belly band and send the information to the medical staff that is in charge to follow the pregnant. So, by working on this joint project with the College of Media Art and Design, I've seen that interdisciplinary research has a strong potential to improve, to provide innovative ideas. But it might also be challenging for two main reasons. The first one is that sometimes it's hard to speak the same language. Because between different fields, sometimes it's hard to explain the design constraints, the manufacturing challenges, and so there is always a trade-off between the material, the manufacturing, and the technological need for our design. We can also have different timings due to the different nature of the disciplines. There might be some delay in providing requested results or prototype. And the value of the request might be an important step that if it's delayed, it may prevent the fast development of the project. So I think that two possible solutions to overcome these issues can be more accurate planning and control of the research and development activity, as well as a standardization and automation of the design project. In the case of Smart Fabric, for example, the development of an integrated system where we can automatically translate the 3D electromagnetic design into the CAD model that is needed by the knitting facilities, it could save a large amount of time. Currently, what we do is to provide the dimension to the knitting facilities, and they have to manually convert this design into the CAD model that is needed for the knitting machines. So in conclusion, we have seen how reconfigurable antennas are gaining importance for our everyday experience with wireless communication. And thanks to their ability to improve the connectivity and reducing the interference, we can take advantage of this technology to develop better products in the wireless market. We have also seen how the interdisciplinary research enables for the integration of wireless technologies into clothing. And after my experience in this joint project, I think that if we can enhance the collaboration and the communication between the different scientific branches, we can develop new successful ideas and successfully apply these ideas to improve our everyday life. Thank you for all your attention.
Are there any quick questions right now, or we'll bring him back up for more questions at the end? But any questions? Any quick questions now? No? Okay. All right. So let's move on to our second speaker, Zhang. So if I read the bio that he sent me exactly, it would land me in front of HR, so I'm not going to read it exactly. But I will say that he did his undergraduate work at Northwest University for Nationalities and Chemical Engineering at he did his master's at East China University of Science and Technology in Chemical Engineering in Shanghai. He's working on his PhD right now at Drexel, working in the Department of Materials Science and Engineering, working with Professor Yuri Vygotsky on research in the area of carbon composites for batteries and supercapacitors. He has many passions, with research being one of them, and I'll let him explain the rest to you. So let's welcome our next speaker.
Does anyone know how to configure a map for this Beyond